A plain old Java object whose acronym is POJO, P-O-J-O, is a class that generally only has instance fields. It's used to house data and pass data between functional classes. It usually has no other or very few methods other than getters and setters for the instance fields. Many database frameworks use POJOs to read data from or to write data to databases, files, or streams. You'll hopefully remember, I've said several times, that a class can be thought of as a super data type. A POJO is really just that. It lets you extend and combine your definition of data types. A POJO also might be called a bean or a Java bean. Maybe you've heard the term Java bean. A Java bean is just a POJO with some extra rules applied to it. These rules are in place so that Java frameworks have a standard way to manipulate and manage these objects. A POJO is sometimes called an entity because it mirrors database entities. Another acronym is DTO for Data Transfer Object. It's a description of an object that can be modelled as just data. There are many generation tools that will turn a data model into generated POJOs or Java beans. You've seen an example of similar code generation in IntelliJ, which allowed me to generate getters, setters, and constructors in a uniform way based on my class's fields. Let's look at an example of a POJO in code. I've created a project called Record Project and created the usual main class with the main method. Now let's say I want to read data out of a database that has a table of student records. So we can see from this that I need 4 fields: ID, name, date of birth, and class list. I'm going to make all of these strings for this exercise. Later in the course I'll make this a lot more interesting with dates, arrays, and custom types. So I'll open the project panel and select the SRC folder. I'll create a new class and I'll call it student. I'll add the 4 fields I talked about as strings. The first one is called ID, then name, date of birth, and finally, class list. So now let's make this a plain old Java object. A POJO in its simplest form requires a way to populate data, and I can do this with a constructor. I'll use IntelliJ's code generation tool to create a constructor using all of these newly created fields. Place the cursor on line 8, then select Code from the menu. Select Generate next, select Constructor, select all the fields, and then click OK. This class, even without getters and setters, lets me create and populate new student objects using just this constructor. And let's do that now in the main method of the main class. Let's take the opportunity to put some of the Java skills you've learnt to date to work. We'll create 5 students in a loop. We'll use the loop variable to create a unique ID. At first, we'll hard code the name as Mary, as well as set date of birth and class list to some literal values. For int I equals 1, I less than or equal to 5, I plus plus, student S equals new student, and the following literal strings in parentheses. S92300 plus I, comma, Mary, comma, the 5th of November 1985, comma, and Java Masterclass. Okay, so here I create 5 student objects. I pass an ID that starts with S92300, then appends the loop index I, so each student has a different ID, and the rest of the values are literals. Let's now replace Mary. I'm going to put a switch expression that'll give me a different name based on the value of the loop index I. Switch on I, and we will return literal strings for each case. A curly left brace. Case 1, switch expression arrow Mary. Case 2, Carol. Case 3, Tim. Case 4, Harry. Case 5, Lisa. Default switch expression arrow anonymous. Right curly brace, comma. So I'm using a switch expression as a parameter to a constructor, which is pretty neat, I think. Maybe you notice that I have a default case label defined, although in this loop it won't ever be true. This is actually a requirement for the switch expression when it's used with a numeric switch value, as we are doing here. It requires that all possible values be resolved, and with a numeric switch value, the only way to really do this is to use a default label, like I did here. The last 2 parameters are simply hard-coded to the same birth date and the class name Java Masterclass. So I can run this, but since there's no output, it's not terribly interesting. I want to show you another generation option on IntelliJ, this one to print out data. When we get to inheritance, I'll explain how this method actually works, but for now, Let's just use it because it really makes life a lot easier. So back to our student Pojo, put your cursor before the last closing brace of the class. We'll pick code and generate, and now look for the option that says to string and select that. Select all fields, then press OK. And now you see I have the code on lines 16 to 23, the method called toString, which will print out all the attributes in my class in a nicely formatted way. So the toString method is a special method in Java. We can implement this method in any class we create, and doing this lets us print out the current state of our object. IntelliJ, when it generates this code, adds a special statement, as you can see here, at override displayed above the method. Anytime you see a statement like this which starts with an @ symbol, this is called an annotation. Annotations are a type of metadata. Metadata is a way to formally describe additional information about our code. Annotations are more structured and have more meaning than comments. This is because they can be used by the compiler or other types of pre-processing functions to get information about the code. And don't worry, I'll be covering annotations in a later section of the course as well as introducing you to the most commonly used ones. Metadata doesn't affect how the code runs, so this code will still run with or without the annotation. This particular annotation we see in this code at override is one of the most common annotations in Java that you'll use. It tells the compiler that this is a special type of method in Java, an overridden method. I talked about overloaded methods quite a bit. An overridden method is not the same thing as an overloaded method. An overridden method is a special method in Java that other classes can implement if they use a specified method signature. Similar to how we create the main method with its special signature, we have to create the toString method a certain way. When we do that, we have access to special Java processing, which I'll show you next. Popping back over to the main class and main method, I can simply print out each one of our student objects using the system.out.println statement. Println s. You might notice that I didn't actually even call the toString method on the student, the s variable in this loop in the println statement. I didn't have to. This is another built-in feature from Java. Every object when passed to println will have the toString method implicitly executed if you've created that method on your class. And now, running this code, I get output. And we can see the data in my 5 student objects. That's another pretty handy code generation tool we can use. So this was a contrived example, but can you imagine if you were reading data from a database or a comma delimited file, how you could create a whole set of Pojos to collect all the data elements in all your records? Once you have all this information in the Pojo, you can pass these objects to whatever code would process it, perhaps generate a mailing list or something else. For good measure, let's add the setters and getters to the Pojo. Going back to the student class, I'll generate those. I think you know how by now, selecting code, then generate and getters and setters. And now my code has all I need to manipulate data. That is, setting, retrieving and updating. We're lucky we have IntelliJ's code generation tool to do so much of this work for us. This kind of code has a name, it's called boilerplate code. It's code that's repetitive and follows a pattern, which is why code generation tools can create it for us. But it's still a lot of code to look at, and I only have 4 fields in my Pojo. Wouldn't it be nice if we had a type that did all this for us and we didn't have to put all this code in our class? Well, we do. Java introduced a new type called the record, which officially became part of Java in JDK 16. I will talk about the record in the next video, so let's move on to that next video.